Now we ask the question if we're choosing some number from some larger number of possible choices. And we're going to let R be the number chosen. We're going to let N be the number of entities from which we make our choices. So we're choosing R from N. Just like we chose 8 from 100 here, we're going to put this into symbols. Well, we can use the fundamental counting principle. We have N choices for the first number. Then how many choices for the first choice? How many choices are we going to have for the second? Well, it's going to be N minus 1 choices for the second. And then there's going to be N minus 2 choices for the third. And we're going to continue this down until we get the rth choice. Now, how many choices are we going to have for choice number R, for our rth choice? How are we going to write that in terms of N and R? You should pause and think about that, but I'm going to go on. You notice that when we made our second choice, we had N minus 1. Our third choice, we had N minus 2. Well, when we get down to choice number 40, let's say we're choosing 40, we're going to have N minus 39, aren't we? Because the number we subtract from N is always 1 less than the number of our choice. Since our first choice, we didn't subtract anything from N. So when we get down to the rth choice, it's going to be N minus R plus 1. So now, what do we get if we apply the fundamental counting principle? Again, you should pause and think that through, but I'm going to write it down now. Hopefully you've paused and thought it through. That means we're going to have N times N minus 1 times N minus 2, dot, 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 as far as it goes, down to N minus R plus 1. That's ordered choices. Now, how many unordered choices would there be? In other words, ordered choices, we're counting different orders of the same group as being different. Unordered choices, as you've seen here, we do something else. Think back to what we did with 108, or 5 and 3, choosing 3 out of 5, choosing 8 out of 100. How are we going to write that down? Now, as a hint, if you didn't yet get it, there are R factorial possible orders for any group of R choices. So any group of R could have appeared in R factorial different ways among this many ordered choices. As a result, we're going to take our number of ordered choices and divide by the number of orders in which any of those choices could be made. And we get our number of unordered choices. Now, how do we write this in terms of factorials? Because, of course, we did that over here. You can think of how we did that here and see if you can come up with the expression over here. Okay, if you write N times N minus 1 times N minus 2 all the way down to 1, and that would be N factorial, and I guess I'd better get this board over here where you can see it. Okay, right, N minus 1, N minus 2 all the way down to 1, that's N factorial. N minus R times N minus R minus 1, N minus R minus 2, etc., down to 3 times 2 times 1, that's going to be N minus R factorial. If we divide this by this, you see all the numbers from N minus R down to 1 are going to divide out of this, and that's just going to leave us what? It's going to leave us only the numbers that are bigger than N minus R. So that's going to be the numbers from N minus R plus 1 on up to N. That's what's going to be left, so that this is what we have. And of course, this is equal to N factorial over N minus R factorial, because our numerator is N factorial, our denominator is N minus R factorial. We give that a name. We call that P of N R equals N factorial over N minus R factorial. Now, if we want unordered choices, what do we do? Well, we did it here already. We divided this, which is just this, which is equal to this, by r factorial, so that there are what we call C of nr, and that equals just P of nr divided by r factorial, and of course that then equals n factorial over n minus r factorial, which is our P of nr, which is this expression. And then we put another r factorial in the denominator. We give P of nr a name. We call that permutations, where order matters. Actually, we use the word permutations to describe when order matters, and then we use P because we use the word permutations. Similarly here, this is combinations. Combinations are when order doesn't matter. So we use C for combination, C of nr. And the application of the fundamental counting principle in many, many cases comes down to simply identifying whether we're choosing permutations or combinations, whether order matters or whether order doesn't matter. So when we're choosing some number of objects out of some other number of objects, if we know what those numbers are, and if we know whether the order is supposed to matter or not, we have a simple formula for either that we can use to find the result. You also have a button on your calculator probably that gives you the permutations or combinations. If you have that button, we usually won't be using that in this course, but when you get out of this course, after you understand these operations, that's going to be very handy in certain courses in certain situations.